In section 5.6, we talk about linear programming. Linear programming is a method for solving problems in which a particular quantity that must be maximized or minimized is limited by other factors. Linear programming is one of the most widely used tools in management science. It helps businesses allocate resources to manufacture products in a way that will maximize profit. Linear programming accounts for more than 50% and perhaps as much as 90% of all computing time used for management decisions in business. An objective function is an algebraic expression in two or more variables describing a quantity that must be maximized or minimized. A student earns $10 per hour for tutoring and $7 per hour as a teacher's aide. Let X be the number of hours each week spent tutoring, and let Y be the number of hours each week spent as a teacher's aide. Write the objective function that describes total weekly earnings. So for objective functions, we use the letter Z. So Z equals. Now, we're going to let X be the number of hours each week she spends tutoring. She gets $10 an hour for tutoring. So we can write this as 10X. But she also gets paid as a teacher's aide. She gets paid $7 an hour for that, and the number of hours each week spent as a teacher's aide is Y. And so that would be the objective function that we would want to maximize for her total weekly earnings. Now, constraints in linear programming. Restrictions such as the maximum weight or volume of a ship can carry are called constraints in linear programming. Each constraint is expressed as a linear inequality, which means it's going to have a greater than or less than sign, something of that nature. The list of constraints forms a system of linear inequalities. So for example number 2, the student in the above example is bound by the following constraints. To have enough time for studies, the student can work no more than 20 hours per week. The tutoring center requires that each tutor spend at least 3 hours per week tutoring. The tutoring center requires that each tutor spend no more than 8 hours per week tutoring. We want to write a system of 3 inequalities that describes these constraints. So she's saying that she can't work more than 20 hours per week. Well, she works 2 different jobs. She tutors and she's an assistant. So the sum of these 2 hours cannot exceed 20. That's the first bullet point. The second one says that the tutoring center requires that each tutor spend at least 3 hours per week tutoring. Okay, so that tells me X, which was the number of hours tutoring. She has to spend at least, which means it has to be greater than 3 hours. And the last bullet point says that the tutoring center requires that each tutor spend no more than 8 hours per week tutoring. So that's a maximum of 8 hours. So X cannot exceed 8. And just as a side note, since we're talking about hours here, both X and Y are going to have to be greater than or equal to 0 because we can't work negative hours. Now, how do we solve problems with linear programming? So we're going to let Z be equal to AX plus BY, and this is going to be the objective function that depends on X and Y. Furthermore, Z is subject to a number of constraints on X and Y. If a maximum or minimum value of Z exists, it can be determined as follows. First, we're going to graph the system of inequalities representing the constraints. Then we're going to find the value of the objective function at each corner or vertex of the graphed region. The maximum and minimum of the objective function occur at one or more of these corner points. So we want to find the value of the objective function z equals 4x plus 3y at each corner of the graphed region and figure out which one provides the maximum value of the objective function. So the points of the vertices are given. We just need to plug them into the objective function. So let's start with 0, 9. We've got z equals 4 times 0 plus 3 times 9. Well, this gives me 0 plus 27, which is 27. Let's do 0, 0 next. Z equals 4 times 0 plus 3 times 0. Well, that's 0 plus 0, which is 0. Let's do 3, 0 next. That's 4 times 3 plus 3 times 0, or 12 plus 0, which is 12. And the last one is 4, 4. So that's 4 times 4 plus 3 times 4. That's 16 plus 12, which is going to give me 28. And since 28 is the biggest number we have here, that means that 4, 4 would be the point that maximizes, and the maximum value is 28. And let's put this all together. For example, number 4, we're going to graph the system of inequalities from example number 2 above. We're going to use only the first quadrant and its boundary because x and y are non-negative. We're going to evaluate the objective function for total weekly earnings at each of the vertices of the graphed region. So I am going to just copy and paste what the objective function was from the first example. That was z equals 10x plus 7y. And let's go ahead and write down all the constraints. X plus y was less than or equal to 20 was one of them. X is greater than or equal to 3 was another. And x is less than or equal to 8 was the last one. So I'm going to number these so you can see where they're at on the graph. So let's plot the second equation first. That's going to be a vertical line, and it's going to be solid at x equals 3. And we are going to shade to the right. For the third equation, that's going to be a vertical line at 8. It's also going to be solid, but we're shading to the left. And remember, we're only working in the first quadrant, which is this quadrant right here. So we don't need to worry about this quadrant or this quadrant or this quadrant. Now let's graph the first one. We need to put it into a form that we know how to graph. X plus y is less than or equal to 20. Let's go ahead and solve for y. Well, that's y is now less than or equal to negative x plus 20. So I'm going to use 4s to go up the y-axis. 4, 8, 12, 16, 20, 24. So this means that we have a y-intercept at 20. And we're going to go all the way down until 20 on the x-axis, which I don't have room for. And we're going to connect our line. This is y is less than or equal to, and so this means that we are shading below. And so because we are dealing only in the first quadrant, that means that my solution set is going to be right here in this region where all three intersect. And so what we need to do is we need to find the vertices of this section. Well, two of them are pretty easy. We've got the point 3, 0. And we also have the point 8, 0. And we need to figure out what the other two are. So we know between the pink and the purple, we know the x value is 3. So we need to plug in to our y function here. So y equals -3 plus 20. Well, that means that y is 17. So we have a point 317. And we want to do the same thing for the blue and the pink intersection. For the other one, we know that the y value is 8. So -8 plus 20 gives you y equals 12. And so our last corner we need to check is 8, 12. We need to plug all of these into the objective function. So let's go ahead and do that. Z equals 10 times 3 plus 7 times 0 gives me $30. Z equals 10 times 8 plus 7 times 0 gives me $80. Z equals 10 times 3 plus 7 times 17 gives me $149. And Z equals 10 times 8 plus 7 times 12 would give me $164. And so because this is the biggest one out of all of them, that means the maximum that she can make in a week is $164. And so what this is saying is she can work 8 hours per week on tutoring, and 12 hours a week being an aide, for $164.